Hello. Video on t-distribution of small sampling and confidence intervals in the MEI S3 syllabus. I put these together because these questions tend to come up, these two components tend to come up in one question in S3. So here's a classic example of that where they want us to carry out a t-test for our hypothesis test, and they want us to find a confidence interval from the same data for a small sample. In this case, somebody's having a bit of a laugh because William Seeley, or if you put his full name, William Seeley Gossett, is student T who created all these statistics whilst working at the Guinness Brewery in Dublin. So best of luck here. So let's have a look at the sort of questions. Again, lots of words. We've got to work out what we want to know. William Seeley Gossett, a biochemistry student, is working in brewery. One of his tasks is to monitor the specific gravity of the brewing mixture, during the brewing process. And for one particular recipe, the specific gravity he required is 1.040. A random sample of 9 measurements from within the mix gives the following data. So that's our test data, isn't it? Test data, 9 items, yeah. Part 1, let's see what they ask us to do. William has to test whether specific gravity meets the mixture, meets the requirements. Why might a t-test be useful for these data, and what assumptions must be made? So here's a sort of classic standard bit we're going to be asked first. Why use t? Yeah, well, we've got 2 reasons. We've got small sample. Yeah, there's only 9 here. So it can't be assumed to be normal, but not normal. Normal under the central limit theorem. And second part is that the population variance is unknown. They haven't told us that, have they? Unknown. So we're going to have to use, so we're going to have to use the sample standard deviation and variance. And what else is it? And what assumptions must be made? This is the final part of our 3-card trick, that the population is normally distributed, yeah. i.e., if we dipped loads of beer and tested its specific gravity, the distribution would be normal. Okay, so there's our 1, 2, 3 points we're making to get 3 marks. Part 2, carry out the test using a significance level. So that's a hypothesis test using a significance level of 10%. Okay, so what's the first thing we have to do then? Is that our hypothesis test, H0. What are we going to say then? In our hypothesis test, our specific gravity here, we're going to be saying that the mean, mu, equals 1.040. That allows us to do all our statistics, doesn't it? Excuse me, I'll just get rid of that there. Shouldn't be there. Oops, forget that set. And what's our alternate? Is that our mean is not, population mean is not 1.040. And remember, we've always got to define for a mark our mean. So our mean is our population. I'd recommend you do that to make sure it's the difference between sample, population mean, and in this case it's specific gravity, isn't it? Gravity of mixture. There we go. You usually get 3 marks for that lot. Okay, so we've set out those. Next thing we need to do is find our test statistic. Well, our test statistic is going to be our t-value from our test data. Yeah, test data. We had our test data above, up the top there. My recommendation would be that we substitute that data, put that data, enter that data into our calculator. Yeah, here we go. So there's our data, there's the 9 items. Then we're going to get the calculator to work out our statistics. So we've got a mean there of 1.0452, that's our x bar. We've got an n of 9, that's what we're expecting, and then our x on this one, I've got x sigma n minus 1. On your calculator, you might just show an s, and that's 0.07155. Yeah, so those are the 3 values that we need to carry out our calculate our work here. So our x bar was 1.0452. Our sample standard deviation is 0.00755, and the sample size n is 9. So we need to find our t. Our t value is our standard form is x bar minus mu over standard deviation of the mean, which is the sample standard deviation over root n. So that's our standard formula. You've got to be able to quote each time. So then we got 10452 minus 1.040 over 0.007155 over root 9, which is 2.189. 2.189 if you put that in your calculator. So we now know what our test statistic is. Yeah, there's our test statistic. Okay, now we need our critical value. Critical value. Okay, and we're going to get that from the t-distribution. We've got a 2-tailed test here. They asked us to use 90%, and it's a 10% significance level. Yep, so we're going to use 90%. Going to need, inside. And then we need our degrees of freedom, don't we? Now, what's our degrees of freedom going to be here? Well, we had a degrees of freedom. We've got a sample of 9. And we know that our totals have to add up to fit in with our mean. We've used it to find our mean, so we've used 1 degree of freedom to find our mean, and so we've got 8 degrees of freedom. Yeah. So if we now go to our tables, I've got those up here. We know that we're looking at a 2-tailed test. So here's the right-hand side, we've got our percentage points of t-distribution. We've got our diagram there, and that shows our probabilities being split. So we're on a 10% in total, and that's being split either end into 5 and 5, but we're only interested in the total here, 10%. And then we are looking at 8 degrees of freedom. So looking down the first column here, and where it meets the v equals 8, we can see our critical value here is 1.860. Yeah, so that's the coincidence of where v equals 8 and p equals 10%. So we've now got 1.860. So our critical value equals 1.860. So now we can carry out our test, and if I draw my diagram here, we're looking at a 2-tailed test. There's our t-distribution, and our critical values are 1.860 and minus 1.860. So we've got 2 critical regions here, haven't we? One at the top and one down the bottom. And then we know that our test statistic in this case is 2.1896. So there's our test statistic would sit here, wouldn't it? 2.189. So what are we looking at? Well, we know that this is significant, don't we? As we're in the critical region. Significant. Always write our comparison. Test statistic is greater than critical value. Test statistic 2.189 is greater than 1.860. Yeah. So we have sufficient evidence to to indicate that specific gravity does not meet requirement, yeah, of this batch. In effect, if this was beer and that was a batch of beer, it would not meet the requirement. So there we are. That's part 2 done. And how many marks we get for that? Get 9 marks for that. Now we've got another 6 marker. Find a 95% confidence interval for the true mean specific gravity of the mixture, and explain what is meant by 95% confidence interval. So you need to have those words off pat, so we'll pick that up in a sec. Here we go then. This is part 3. They want a 95% confidence interval, yeah? Confidence interval. Okay, well, how do we calculate confidence interval? We've got a general formula. Our confidence interval is going to be our sample mean plus or minus a t value related to our confidence interval, our percentage, and also our degrees of freedom. And then we've got to multiply that by our s over root n. So effectively, we've rearranged our original formula and put it in the other format to find our maximum and min point. So that's what we're looking for. Now we know what x bar is. We don't want to know what this beastie here is yet, do we? So what's our t value going to be? Well, we're on a 95%, and that's on a 2 tail in effect, isn't it? And we've got, again, our 9 minus 1, we've got 8 degrees of freedom. Yeah, so what we're doing here is we're creating something that looks like that, aren't we? We're going to create a range, and this middle bit here is going to be 95%. Okay, so if we go back to our tables here, we've got 8 degrees of freedom as we had before, but rather than having 10% in total outside our band, we actually only got 5% now, haven't we? Got 2.5% at either end because 95% is inside. So go down that column until we intersect with the v equals 8, and we come up with a t value of 2.306. Okay, so that value there is going to be 2.306. And now we can create our confidence interval because we've got our sample mean 1.0452 plus or minus. We're going to go 2.306 mean sample, so standard deviations for a mean, which is our standard error, and that is 0.007155 over our root 9. There we go. And put that in our calculator, we get 1.0452 plus or minus 0.0055, and we need to write it as an interval always. So our range is going to be 1.0397 and 1.0507. So there's our interval, yeah. So if we looked in our diagram here, looking above, we had a mean of 1.0452, and we got our rate, we've got 95% in here, so our lower value is 0.397, and the upper value is 1.0507. There we go. So that in effect is our confidence interval. And then they asked us to define what a confidence interval is. So confidence interval, what a 95% confidence interval is. Okay, and we need to say the following words almost exactly as I'm going to write them. In repeated sampling, yeah, so that's not just one off, but in large numbers, 95% of the confidence intervals constructed in this way will contain the true population mean. Okay, so that's what we need to be saying for MEI in all of these, in what does this mean. Okay, so to conclude this, and my little summary as ever, t-distribution is used to investigate populations where the standard deviation is not known, a sample is small, and therefore the sample standard deviation must be used. Here's our definition of our test statistic, the t-value, and we use that for our hypothesis testing against a t-distribution critical value, and they could, all these t-distribution values can be got from our calculator or from our tables. If we're finding a confidence interval, we're using this formula here, and if we're using the t-distribution, we need to look up the t-value from our percentage and degrees of freedom to put into the formula. And if you're asked to define what a confidence, explain what it means, confidence interval, then we've got this wording down the bottom. In repeated sampling, 95% of confidence intervals constructed in this way will, excuse me, it should be just will, contain the true population mean. So there you are. I hope that's of use, and good luck.